my video. My name is Rizwan Ye. I'm a student at University of Technology Sydney and major in Artificial Intelligence and Data Analytics with honours. In this presentation, I'll be talking about my final honours project, which is about enhancing XAI interpretability by using a rated chart to simplify feature-based explanations and reducing cognitive load. Basically, for this project, I've done an empirical survey to measure the different types of XAI explanations combined with a rated chart. Also, I built a web application that implements an explainable artificial intelligence program, which is LIME, and also used a rated chart and also used a language model to help explain the outcome. So for this project, my supervisor was Shoujin Wang, and my previous supervisor was Jianlong Zhou. Just to give an overview of this presentation, I'll firstly just talk about the background and importance of XAI and my research, followed by the designs that I made for both my chart design, server design, and the development of a web application, and followed by just the results and discussion of the entire project. So if you want to skip some sections or jump ahead, there are timestamps at the bottom of this video for you to navigate each section. So one of the main problems with machine learning and artificial intelligence is that nowadays these models are becoming more complex, and as a result, it is becoming more of a black box, which makes it difficult to understand for end users. So for my research, basically I'll be focusing on studying the type of explanations and measuring the cognitive load of these explanations. This was the rated chart, language model explanation, and just a traditional XAI visualization. So based on my survey, I found that rated chart and language models was good solutions to improve the end user understandabilities. And based on this result, I also implemented a web application using Streamlit to demonstrate its capability for improving the understandability of a learning application that uses a language machine learning model design. In the context of the current XAI environment, we can see that researchers suggest two main things to improve the understandability of these complex models. The first thing is to utilize an intrinsically interpretable model, for example, using a simple model rather than a deep learning model. But in the real world, when we look at these type of solutions, we can see it's kind of problematic because most organizations have already implemented a very, very complex model designed, for example, the banking industry. So the banking industry normally uses deep learning models trained on hundreds of thousands of data points using a very complex model. So these type of things are already built into the business, so it's very hard for them to change. So the second thing is to use a post hoc methodology. This means to use an extra model after or on top of the current model to explain the outcome. So this is one of the more research areas in this field due to its potential, and also it doesn't modify the current model. So businesses really like this type of solution. So for my study, I focus on the post hoc methodology, namely the visual explainable AI side, so vXAI. So in the context of a learning application, I decided to do this because I found that a lot of researchers often overlook this area of focusing the explainable side to end users that don't have a technical background. So just to give an overview of how XAI and my research is beneficial to the field of computer science and artificial intelligence, we can look at the diagram here. So the first diagram in today's world, we can see that let's say we have a training data that's pushed into a machine learning program that outputs some type of result. So you can see the end user there is kind of confused. So they might have some questions like, why did it output this result? Why didn't it choose something else? Or why did it fail? Or why should they even trust the output? So these type of questions, the end users that use these programs really want to have an answer to. So it's especially important for the banking industry, and especially important for regulators as well, and some ethics as well. So some programs might be biased to certain groups. So these type of outputs are very important for the end user. So the way XAI programs help is, you can see there's two extra things that they output. So they use a explainable model and an explanation interface. So for my research, I focus more on the explanation interface in a way that I helped improve the end user's understandability. So in doing so, we can help them ask better questions, help them understand things. So for example, we see in the diagram here, the end user can understand why a certain outcome was outputted and what type of features are involved and what type of explanations and what type of things that they can ask the end output. So these things can help improve the understandability rather than have a binary classification that's normally outputted in the real world saying that someone was declined a loan because they were just declined, or we just accepted your loan because we accepted it. So this is the way that XAI can really help in the real world environment. In this diagram, I found it on the DARPA's research website. So you can see that in the field of the explainable artificial intelligence side, there are three main things. This is the machine learning side, the end user, and the human interaction side. So these are the three main things that researchers focus on to improve AI and ML interpretability. So since a lot of researchers are quite technical, they mainly focus on XAI and machine learning development. There is a lot of research papers focus on type of algorithms they can implement and how they can build these algorithms to help understand the machine learning output. But however, for my current research, I focus on the other two, which is I focus on the end user explanation and the human interaction side of things. So this is mainly for me the radar chart design, which is the visual analytics side, and the human interaction side, which is my web application that I built using Streamlit, and also it also uses a language model to help explain the output. So this is just a diagram that I built to further explain my research. In the middle, we can see that the focus of this research is focused in the post-hoc explanation side of explainable artificial intelligence, and I combined three main things. This was the visual analytics, design of the visual graph to help improve analytical reasoning and understandability for the end user, and also combining it using cognitive load. So cognitive load is a psychology term mainly used in psychology research. It is just a measure of mental effort an individual exerts when they look at something. So when we talk about cognitive load, we want to have something that's optimum cognitive load, something that's low and not high. So this means we want a cognitive load that promotes an end user's understandability and also helps them learn something as well. Another thing as well I like to add is model agnostic. This means that we want an explanation that is adaptive, something that can be used in one model can also be used in another model. So we're combining these three main areas of research. This is what I focus on in my current topic. So when we look in the current environment of XAI, we don't really see this type of combination of research because a lot of people don't really focus on end users. So this is something I believe is quite innovative, and we don't really see this a lot in the research field. So I think by improving into these three main things, we can help with the end users' understandability. So this is just a timeline of my honors project. My honors project was 13 to 14 weeks in total, and majority of it was conducting an exploratory research and look at the current dynamics of the environment in the field of XAI and AI and visual analytics. After researching it, I based my fundamental understanding to build a machine learning XAI model to generate a radar graph. That this was all done using Jupyter Notebook, and afterwards all the results that I had, I pushed it into a radar chart development and just generating some visualizations to help used in the empirical survey, which was launched afterwards, which used the Likert scale to ask end users some questions about what they feel of the explanations that they see. And this was all done online as well. And finally, this was all combined together, the results and the things that are built into a web application using Streamlit. So the Streamlit application was just a working prototype just to demonstrate how the result will work in the real world environment. There were three main stages and types of radar charts that I designed for my honors project. So for the initial design, it was just using a traditional radar chart that I built using Matplotlib. So when I looked into this initial design, my interpretation was that it has a high cognitive load because there's a lot of clutter and annotations involved with explaining the output. So you can see like there's an area involved as well in the diagram, and there's a lot of data points and there's a lot of annotations. So this is just a traditional radar chart that a lot of people use, but for my interpretation, I believe that it looks very confusing for the end user, especially if they didn't have any type of understanding or seeing these type of visualizations before. So the second design that I done was it was an experimentation design to make another unique visualization. So during this stage, I felt this design was really good because it limited all the clutter and just output the main features. So this was launched into the survey to research the end user's cognitive load. So this is what I plan to use in my original design previously to launch into a web application. So I've done some testing afterwards after the empirical survey to build another visualization, which was the final iteration of the radar chart design that I did. So this had some customizations that I added on top, which is like reordering the features weight in ascending order, and also color mapping each feature score and adding the sizing as well. As you can see, the sizing when feature score is increased, the sizing of the bar chart in the radar graph also increases as well. So this is to demonstrate the weight importance of a feature towards machine learning output of a classification. So one of the main reasons I opted for this design was because I mainly based design based on the Gaslit design principle, which is utilizing continuity and congruity to improve perceptual visualization. So we can see the last visualization was actually very, very improved compared to the other two iterations. So this is the final one that I actually launched on my prototype web application. In this slide, I'm just going to talk more about just the logic of my survey design. So there are three main goals of my empirical survey, which was firstly just to confirm my hypothesis that charts was a good solution to visualize the XAI output and also show the effectiveness of the chart for enhancing an individual's understanding combined with how it compares with the other explanations that we launched. So if you look into the flow diagram here, in the top right, we can see that it's just the three main surveys that was launched. So this was just like the original rated chart, the language model output that I kind of used to explain like the explanation of like the XAI output, and lastly, it was just a Lime XAI output. So the Lime explanation is just kind of like a bar chart that the developers kind of used with some kind of statistical numbers. So um, in terms of the implementation of the survey itself, I used Likert scale rating. So Likert scales are commonly recommended in cognitive load research. Basically, what it is just a rating scale. So from 1 to 5, the end user will pick 1 being like, for example, the most hardest, or 5 being most easiest type of viewpoint that they have. So it's just more of a subjective rating that the end user has. And in terms of the medium that I used to launch the survey, it was launched in platforms such as Facebook and Facebook groups, and to people such as family and friends, just to ask them to share the survey. And I also used another survey online, which is kind of a paid platform, but they had a free trial, which is SurveyMonkey. So you kind of like pay people to do your survey. So because it was a free trial, I kind of just tested it around and just get some insights. And for the questions that was asked within the survey itself, it consists of three main things. So it's kind of like a visual search task. So for example, I asked end user in this visualization radar chart, what is the like feature value of, for example, income? And they will click the answer, and also they'll ask themselves a cognitive load rating. So how easy was it to pick this? How hard was it to pick this? And also I asked them things such as the perceived visual clarity of the graph. So on a rating 1 to 5, would you use this graph, or how clear do you find this graph? So this is something that I asked the end user. And I also want to mention as well, there is a limitation of budget and time in this project. So in Cognote, there's three main things of rating cognitive of an individual, which is the subject rating, the performance, and psychological measures. So I only focus on the subjective rating, which is just asking the end user to rate themselves rather than the performance or psychological measures, because these type of things you need to go face to face with them to see their actual performance. So I couldn't do that due to the limitation of time that I had. So since my project could not go in depth into the survey, I decided to go wider. So I decided to have a larger scope of my project, which is to do a survey to just confirm my original hypothesis, and also build an application on top just to improve the scope, to show that the type of feasibility that we could do in explainable artificial intelligence research. So for my machine learning and explainable artificial intelligence development, this was just the back end of my web application. So this is the final model that I utilized. The dataset I used was from Analytics Video, which had approximately 600 data points and 11 features, including the target variable. So this was the final dataset I used that had like everything else removed, the unnecessary features included as well. And what I did here for dataset augmentation is just some basic feature engineering that I did to transform the dataset. For example, just like binarizing the categorical variables into like 0, 1, 2, 3, just for it to be used in the machine learning algorithm. So for the machine learning algorithm, I used a decision tree. So I decided to use this simple algorithm because accuracy wasn't important and it was quite simple to just implement as well. And I wasn't focused on the classification in performance, so I didn't want like a deep learning model which might cause some problems in the future for the line model. So I just done something simple that wouldn't cause much issues. So for the line model, namely what I did here is I just done some like feature engineering for the output. For example, if it classified like an individual that was declined a loan, I inverse the value. So normally like when someone was declined a loan, it will output negative values, which would cause a lot of issues for the radar graph visualization. So I had to inverse it to make it a positive value and kind of change things around there. And also for the feature engineering output as well, because line doesn't output values in a good format for the statistics. I had to do some augmentation in just kind of like stripping the values itself and reordering it into like feature name and feature score. So this is what I did for the output. And for the limitations of the research here is that I had a lot of time limitation and also research capability limitation. So I had to sacrifice the accuracy score and the dataset as well. There wasn't much datasets I could find that I could use for my type of study. So these things were sacrificed in order to make a working application and in order to spend more time into the empirical survey as well. In the next few slides, I'm just going to talk about my web application design. If you want to see the actual web application, I'm just going to attach a video in the description for you to click on to see the actual demonstration. Also, the code will be on my GitHub as well, which I'll attach in the description as well. So in this diagram here, it's just a simplified version of my actual web application. So basically, there's a navigation bar at the homepage, and the homepage will have some information which the user can read about how the web app works, and also a button for them to click to go to the XAI application. So the XAI application allows a user input to input the values. For the input values, there's things like, for example, how much income they expect to receive and how much loan they expect to ask for, and some data types that can be pushed into the machine learning XAI platform. So after the user has inputted this, there is a button that they click, which runs the entire program itself. So we can see there is a radar graph chart that will be outputted, and there's also be the language model annotator that will output the information as well. So this is just the web application design that for my homepage. So the homepage I added like, for example, a favicon on the top of the website. There is a logo design that I did, a navigation bar to go from homepage to the application page, and the button as well goes to the application page, and just some simple context information that the end user can read on how to utilize this type of platform. This is just my application page. So before the backend actually runs, it needs to have input from the end user. So on the sidebar here, we can see there is some like inputs that the customer can use. For example, like changing their gender and like choosing some type of values that I have over here. And it can be scrolled down as well. Just has all the data points that the machine learning model and XAI application needs to have before it running. So in order for this to happen, when the user choose their male, it will say like choose one binary, one for male, and female binary 0. So this is just use if else statements to be stored or into the data frame. So this is what normally has to work. So if the end user doesn't pick anything, will just run as binary 0 or runs the default settings. And after they've inputted all these values, they can click on the button on the right hand side. You can see it says click to calculate the loan eligibility, and doing so, this will run the entire backend program and starts doing some calculation to output the rated chart and output the language model annotation as well. This is now the output of the program after the end user has inputted all the values. So the first thing we can see here is that there is just some general text that is outputted. So the annotation text will just be a binary output, so 0 as in no, 1 as in yes. So in this case, the end user has their loan approved, so it triggered a binary 1 as in yes. And it will output a statement as it has been approved. You can look at the red graph below, which will show the features we calculated to output your result. And looking into the red graph itself, basically what I did here is I showed the data feature significance as in ascending order. So the most not considered to the highest most considered for the output itself. So we can see here it's the rule is negative to low contribution, and marriage and applicant income had a high contribution. So this shows that to the end user that maybe they want to have a high income, or maybe they want to stay not married for this loan to be approved or to get future loans. So this is just something that can show to the end user what type of significance each feature has to the outcome, and what other features aren't really considered to the outcome of the loan application. So this can give them some type of just a visual insight to the application. So this is the final output of the program. So first thing we can see, before when the rated chart was actually output, there is also a legend to show the feature significance. So we can see dark color is not feature significant, and the brighter color is feature significant to the positive rate positive application. So if the client has approved yes, it will show the score as brighter orange color for the feature significance. So we can see here there is the output of the annotation. So at the bottom, the output of the annotation, it is I used the language model from GPT-4. Specifically, it is the Orca Mini, which is running locally on my computer. So this Orca Mini size is around 9 gigabytes. So in computer terms, it's very big, but in language model terms, it's actually a very, very small size. So there are language models that are over 50 gigabytes that are much more smarter in terms of explanation. Also, in this case, because of budget constraints, I didn't use the ChatGPT 4.0 API because it is quite computationally expensive to run each iteration. So it costs around depending on the model you use, it might cost 50 cents per time you run the application. So depending on how I use it, it can be quite costly in the long term. So I use this locally, and I didn't use a big program that's had a lot of space requirements. So we see it just generated a small annotation of the output, just a basic description of what each term meant and how it affects the overall application. So this is just a demonstration, but in the real world, if there is a much more smarter language model, the output will be much more accurate and much more explainable to the end user. And finally, we're at the end of this presentation. So I'll talk more about the results and discussion of my entire honors project. So when I was doing the empirical study, I found that the rate chart actually had the lowest or the best cognitive load compared to the annotation and the traditional XAI visualization. Also, we want to mention that the empirical survey was quite limited as well. So there are possibilities of bias and overgeneralizations of the results due to the low amount of people that actually use the actual survey itself. So also I want to say that the rated charts are actually very customizable and adaptive. So in the future, it can be beneficial to use this visualization in XAI feature-based results, especially when researchers in post hoc explanations really want to look for model agnostic developments. So rated charts can be quite adaptive in explanations that are actually model agnostic. So because of how customizable it is, it can be quite model agnostic. So also, in terms of the ray chart and combining the explanation with a language model, it can help with providing the end user with appropriate context to understand the result. So, for example, if the end user doesn't have technical understanding, they might want more information. Language models in this case can help them understand more about the application itself. So they don't really need to, like, for example, call like someone else to explain it to them. They can just get just an automatic response from the computer. So in terms of my prototype, the XAI bank that I used, it showed that ray chart and language model can be deployed in the real world environment to help users understand the complex AI ML outputs. So, from my research and looking at like videos online, there's not a lot of people actually doing this type of research or doing these type of demonstrations. So, I think my actual research in my honors project is quite innovative and can show to the people in the real world environment how we can actually use this to help improve the transparency of machine learning and complex AI programs for non-technical stakeholders. So in the future, when we want to focus more of the end user and focus more on the interface design, we can do what's called vXAI, also known as Visual Experimental Artificial Intelligence Research, and combining it with cognitive load. So this will help solidify our research and help solidify our findings. So this is the type of things that I found overall in my research. So I'd like to thank you all for listening to our presentation. This was presented by myself, Rizwan Ye. I'm a student at UTS. Also, I'd like to thank my supervisor in this honors project, Shoujin Wang. He accepted my project at the last minute when I couldn't find another supervisor, so he made this project feasible. And also my previous supervisor as well, Jianlong, so he helped with providing me just the insights of XAI and cognitive load and just tying these two terms together. So I'd like to thank both of them. And also for the demonstration of my project, I'll attach a video link in this description just to show how the actual application will work itself.